Assalamualaikum and hi. In this video, our group will present about permanent magnet moving coil. And first of all, what is PMMC? As we know, PMMC, the short name for the permanent magnet moving coil, uh, is an electrical measuring instrument that is mainly used to measure direct current or DC we call it. And PMMC is an analog device where the movement of a pointer will indicate the value of current or voltage. Also, PMMC instruments are well known for their high accuracies and sensitivity, which make them suitable for the laboratory and educational use. And for the overview, in general, PMMC is commonly used in DC emitter and voltmeter. One of its main advantages is that it provides a uniform and linear scale, which makes the reading more easy and precise. But PMMC instrument can only be used for DC, direct current measurement, not for the AC, because in the AC circuit, the current will always change and the pointer will not at stable position, so we cannot read the reading. Due to the reliability and accuracy of PMMC, this instrument plays an important role in basic electrical and instrumentation study. But how it works, how the operating principle of PMMC. So this is how operating principle of PMMC. PMMC, when the current carrying conductor is placed in a magnetic field, it experiences a force. This concept can be explained using Fleming left-hand rule, where the forefinger will represent the magnetic field, and the middle finger will represent the direction of current, and the thumb will represent the direction of force. So in PMCC instrument, when the current flow through the coil, as we see that we have the two permanent magnet surrounded the coil. So when the current flow through the coil, the permanent magnet will produce an electromagnetic force, and this force will this force will cause the coil to rotate and create the deflection torque. So the amount of deflection torque is directly proportional to the current flowing in the coil. So in a PMMC, we have a control spring that provide a restoring torque to balance the movement, and we will achieve a damping using the eddy current. So when the both torque are balanced, the pointer will settle at a stable position, giving an accurate reading. And that's how operating principle of PMMC. That's all.
Moving on to the constructions of PMMC. So PMMC actually have a lot of main components that work together so that the PMMC is functioning. And in our presentations, I would highlight five main components of PMMC. So the first component is the permanent magnet. The permanent magnet is used to create a constant or a strong uniform magnetic field that interacts with the coil's electromagnetic field when the coil receives the current from the source. And I would say this permanent magnet is actually can be considered the heart of the PMMC. And moving on to the moving coil. So actually moving coil is the rotating element and it carries the current we intend to measure. When current flows, the coil reacts to the magnetic field and begins to rotate. And thirdly is the soft iron core. So basically inside the coil is the soft iron core, and this is very important because it increases magnetic flux density and will significantly boosting the instrument sensitivity to even small currents. And second last is the indications, which is the pointer. So the pointer moves across a calibrated scale to indicate the specific voltage or current magnitude. And actually, we also include a mirror to help avoid parallax errors during reading. And lastly, is about the control and support, which is the spiral springs. So in order to manage the movement, we use spiral springs which provide the controlling torque to oppose the coil's motions. And this entire assembly sits on pivot and jewel bearings to minimize friction and ensure smooth rotations. That's all from constructions of PMMC. Thank you very much.
Okay, so for my part, I will explain the working characteristics of the PMMC ammeter. When the DC current flows through the moving coil placed in the permanent magnetic field, a deflecting torque is produced, which causes the pointer to move. At the same time, a controlling torque is provided by the springs, which opposes the motion of the coil. The pointer comes to rest when the deflecting torque is equal to the controlling torque. Because the deflecting torque is directly proportional to the current, the deflection of the pointer is also directly proportional to the current. As a result, the PMMC ammeter has a linear and uniformly spaced scale, which makes the reading easy to observe and accurate. And next slide, I will talk about the sensitivity and accuracy of the PMMC ammeter. Sensitivity refers to the ability of the instrument to detect small changes in current. PMMC ammeters have high sensitivity due to their strong permanent magnetic field and the lightweight moving coil. This allows the instrument to respond to very small DC currents. In terms of accuracy, PMMC ammeters provide accurate measurements because of their linear scale, stable operating mechanism, and low friction in the moving system. Therefore, PMMC ammeters are suitable for precise DC current measurements, especially for DC applications. And lastly, I will explain the calibration of the PMMC ammeter. Calibration is carried out to ensure that the ammeter continues to give accurate readings over time. This is important because factors such as aging of the permanent magnet and changes in the spring characteristics can affect the accuracy of the instrument. One common calibration method is the comparison method, where the PMMC ammeter under test is connected in series with a standard ammeter. Since the same current flows through both instruments, the reading of the PMMC ammeter can be compared with the standard value to identify any error. Through calibration, measurement errors can be detected and corrected, ensuring reliable operation of the PMMC ammeter. And that's all from me.
Hello, I'm Li Xunyuan. Now I will talking about the application of PMMC. First, PMMC instruments are widely used as DC ammeters. They are used in electronic circuits to measure direct currents. By using PMMC ammeters, we can know how much current is flowing in the circuits. This is very helpful for testing and checking circuit performance. Second, PMMC ammeters are commonly used in laboratories and schools. In lab experiments, students use PMMC ammeters to measure DC currents and observe pointer movements. This helps students understand basic electrical principles in a clear and visual way. Third, PMMC ammeters are used in battery systems. They are used to monitoring charging and discharging currents. This is important because it helps us check the condition and performance of batteries, such as automotive system and energy storage system. Finally, PMMC-based DC ammeters are installed as panel-mounted instruments in power supply units. They are usually placed on the front panel. This allows user to monitoring output current easily. By doing this, the current can kept within a safe operating range, and and damage to connect devices can prevent. In conclusion, PMMC emitters are simple, reliable, and widely used. They play an important role in electronic circuits, laboratories, battery systems, and power supplies. Thank you.
Next up, I'll talk about the advantages and limitations of PMMC. So first, the advantages. PMMC instruments are widely used because they provide very accurate, stable, and reliable readings when measuring direct current. They also have high sensitivity and consume very little power, which is important when working with low current electronic circuits such as those involving resistors, transistors, and communication devices. In addition, PMMC meters have smooth and steady pointer movement, making them ideal for observing small changes in current. And next, the limitations. PMMC are designed only for direct current and cannot measure alternating current without the use of rectifiers, which adds complexity and may reduce accuracy. PMMC meters are relatively sensitive to mechanical shock and overload, meaning they can be easily damaged if not handled carefully. Changes in temperature and the gradual weakening of the permanent magnet over time can also affect their accuracy. Furthermore, they are not suitable for measuring very large currents directly, as they require shunts for high current applications. Let's move on to the conclusion. So PMMC is a precise device for DC measurement operating on the interaction between a permanent magnetic field and a current-carrying coil to produce a deflection proportional to the current. It offers high accuracy, sensitivity, and low power consumption. Despite being limited to DC measurements and affected by temperature and magnetic effects, PMMC instruments remain widely used due to their stability and reliable performance. That's all for our presentation of our group. Thank you so much for listening.